Okay, I think we are live. So I am back in live after 1 year, and today I'm going to talk about keypaths. But before diving deep into the keypath, let's see a few highlights. Okay, so here I have explained today's agenda and what and why of keypaths. So keypath is simply a declarative, safe and composable way to access data in Rust. Okay, it is inspired by Swift keypath system and Haskell lens. It is type safe data access, compile time checked, composable, support memory containers and locks, DSL friendly, functional style, reflection free, and help us to write parallel code. So these all are highlights. Let's see a small example of deeply nested struct written in Swift and Rust. So left side is our Rust keypath syntax and right side is Swift keypath syntax. Here main highlights are this SUR operator. So currently we are using dot then syntax in order to make a keypath chain, while in future version of Rust we are going to use SUR operator in order to chain our key path. So this is how Swift create a functional chain of key path and then get data from it, while this is how Rust is going to create a functional chain of key path and then going to get data from one instance. Second main highlight is here we need to add dry macro kb in order to create associative function of key paths with the same name of field. So here field 1 functional key path will be created with associative function inside L1 struct with the same name as of field. So this is how we are going to create functional chain to access some data. So next we are going to see imperative versus declarative syntax key difference. So there are several difference between coding style, but a major one to highlight is that we are going to focus on vote in declarative style, while in imperative style we focus mainly on how we are going to access something or how we are going to do things. So these are main highlight. Other than that, declarative syntax are easy to parallelize and modify. It is more testable, easy to read, and supported by Rust Path library, while normal imperative code is native support to Rust programming language. So here is the installation guide. We can start our journey of KeyPath in Rust by adding these two dependency in our Rust project cargo.toml file, or we can run cargo add command at the root directory of project or our key space. We can optionally add some features like parking lot and Tokyo in order to add additional functionality of using RW lock and mutex of Tokyo and parking lot. So let's see a small demo where I will be explaining two things. First one is declarative versus imperative approach of accessing data. I'm not going to cover entire declarative or functional programming. I am going to focus more on accessing deep data from deeply nested struct. So this is one of the main part of functional programming or declarative style of coding, and this is what I am going to focus today. So we have two example here, but first let's see our dependency. So here I am using VS Code IDE, and I have already installed Rust in my MacBook. You can follow any YouTube video tutorial to set up Rust environment for coding. So this is not my scope. I am directly going to explain you about KeyPath instead of explaining how can we get started in Rust. So this session is not about how to get started in Rust, while it is more focusing on some, we can call it advanced feature of declarative design or functional design of coding. So after adding these two dependency in our project, we will be starting from here. So if I try to explain basics of key path, then we can create any struct or enum. Then we have some field, let's say string type. Then we have a main function. So here, if I try to access some associated function, so the very simple syntax. So this kind of function is called associative function, where we are not accessing self. So that's why we don't need any instance in order to access this function. But how can we call this function? By using this struct name followed by the function name. So this is how we access associative function. If you understand associative function, you are qualified to use Rust KeyPath in your code base. So let's start with KeyPath. So here I have one example where I have defined two struct level 1 and level 2. Okay, so here let me make it. Okay, so here I have created two struct level 1 and level 2. Both are having some field, some are option type, some are non-optional type. So let's see how can we write code in order to access these field in imperative versus declarative way. So this is imperative way. So in imperative way we use either unwraps or if let chain or and then syntax in order to access these fields. So main highlight in imperative style is we are defining behavior that how we are going to access our field 2 from the instance of level 1 struct. If our field 3 is option, then either we are going to use optional chain, if let chain, or we are going to use unwrap in order to access this field. So as soon as I am going to add option here, I will have to either add if let syntax or unwraps or unwrapper default. So this is where we are defining how our code is going to access these fields. While in declarative style, we are creating functional chains and composing it in order to access the fields. So here is one of the example where we are accessing field 3 that is chained inside level 2 struct. Okay, so here we can see how we are using associated function that returns a functional component that is called KeyPath. We are chaining with then function, and then we are using get and get mute in order to get the exclusive instance, that is result. We can also write it in more functional style. So we can use dot map. Yeah, so this is more simpler code. So let's talk about major highlight from this code. So one of the major highlight here is associative function that automatically got generated when we mark our struct with kp drive macro. Second highlight is then operator that will be further replaced with sir operator in future. Third highlight is get. So we have two function get and get mute in order to get the data from instance. So if you won't write this get or get mute, it won't ask you for instance and you will be writing pure functional chain. So this is pure functional chain. This is third major highlight. We are creating code that is accessing field 2 without the need of any instance. So this is functional way of accessing data. We can write some generic code that doesn't really care about any container or sort of any kind of type. It can be either struct or enum. We can write some generic code on top of keypath that further utilize these function chain. So again, if we try to remove instance then there is no way in Rust that we can do it without instance. So these are some major highlight of KeyPath. We can form some functional chain without actually needing of the real instance. And whenever we want to generate output from our functional chain of functional code, we are going to call get or get mute, and then further going to get data. So if we want to call get mute, then we need to share mutable instance, or we have to borrow it mutably. Hmm. So we have to borrow it mutably in order to give mutable instance of that field. Now this result is mutable. So these are major highlight of keypath syntax. Now further we are going to see some practical example from our Rust keypath crate. Okay, so I am going to use this example to demonstrate some real life use case of deeply nested struct. You can use this MD as skill for your LLM or SML in order to uh, train your model with keypath syntax. Okay, so let's copy paste this code. So here we can see a much more complex example where we are trying to access some field that are deeply nested. So this structure is further nested here, and then it is further having one more struct in it, and then this struct is further having two field. One is option string and another one is some enum, and then also this enum has some variant. These variant further have some more struct, and then finally we want to access this field, this deeply nested field, DSF field. So this is our initializer, and this is our simple code to access this field. What we are actually doing, again, this kp drive macro is generating some associated function that returning key path. This key path is going from struct to that field. Then further we are chaining on this key path with next field, and that next field belongs to further this struct. Vice versa, we are going to make a chain until we reach this field. Finally, we have this get mute and get function written on top of key path that take one root instance and return value that we want to access. So here in this case we have DSF field. So we are getting axis of DSF field, and further we can run this example. Further we can run this example and we can see that our DSF field is changed. Here we can see our DSF field is changing, while this DSF field initially having some value, some string value, it is replaced with this string. Now let's talk about power of KeyPath. So let's say we have written some very important validation or some anything that we want to do with this nested struct. We have written on top of KeyPath, and now some requirement come up where we we either need to remove some option. For now I am going to return to do here to make our compiler happy. Okay, so now we can clearly see in our functional change we do not have to change anything, while we have changed this sum enum from option to non-option field. This is one of the benefit of using KeyPath. We are writing a code that is more stable and more adaptable to adapt changes occur from uh, changing this changing container type. We can put this field into one container and we can see we do not have to change anything in our logical part of the code. While if we were using imperative approach where we declare how of each and everything, then we have to especially mention that how we are going to extract data from option and from box. So these are major highlights of using functional chains. So here then so this is one example. Another we can try with box. I think we can also make any number of like valid code, valid combination of containers. Then further we can update here as well. We can use RC instead of box, and our code will still compile. Our code will still work. Okay, so code is crashing because we have edit to do here. Thanks all. All right. So because I am live, I am not updating all these fields. Okay, so we can change this with RC, reference counting. Then further here we have, let's change another field, some easy peasy one. So let me try to use RC or box here. Then further I need to add these two field into box. Dot box. Let's add it in option and see. Oh, let's add this in option and see. So I think we need to work on box type. We should get inner version of box. Okay, I'll write it down and make it a fix. But this is all about our KeyPath library. It is constantly updating and accepting all the new changes, all the new container like we found here, and that's all I think. Okay, so let's wrap it up quickly. So this is a small hint of imperative versus declarative style of validation where we are defining, we are focusing on how a validation should happen versus what should happen in a validation. And this is also a hint for uh, for this. We can run this code in parallel. So that's all about Trust Key Path. Uh, and lastly, hello there, I am Akash. I am currently working at NPCI, previously working in CFPL and Tokopedia. You can follow me on LinkedIn and GitHub by scanning this QR code. Thanks for your time. Have a nice week ahead.